Issue 307, Weekly Puzzle. This week's puzzle. This square of side 12 centimetres is split up into 4 sections by drawing 2 lines. One is diagonal and the other joins one corner with the midpoint of the opposite side. What are the areas of the 4 sections? Well, here's the square. Each side is 12 centimetres. That means the whole area is going to be 12 times 12, which is 144. It's in centimetres, but I'll just leave it as numbers just now. Well, this looks like a case for simultaneous equations. What have we got? Well, a diagonal quite clearly cuts things in half. So I know that A plus B, being the top half, must be half of 144 is 72. And D plus C, being the bottom half, must also be 72. This part here, if that just goes to the midpoint, then that's going to be 1/4 of it, meaning that A plus D is going to be 1/4 of 144, which is 36, meaning that this part here will be 3/4 of it. B plus C is going to be 3/4 of it, which would be the remainder 108. Let me just put a note again here. A plus D equals 1/4 of 144. Now, if you've got 4 unknowns, you require 4 equations, and that certainly looks like 4 equations. But don't waste your time trying to sort this out, because it won't work. You need 4 independent equations. They have to be what's known as linearly independent, and these equations are not linearly independent. Linearly independent means, let's put a wee note, linearly independent means I can't make any one of these by taking combinations of any of the others. Linear combinations, as in multiplying by a scalar, a single number, and adding or subtracting. These are not linearly independent because, for instance, I can make this one here, B plus C equals, by adding these two, then I've got A plus B plus C plus D equals whatever, and taking away the A and the D, I'd be left with B plus C equals. I'd end up with this one again. They're not linearly independent, so I can't use these to get the solution. I've got 3 independent equations here, but I don't have 4, so I need one more. And that other one comes from these similar triangles A and C. I've got this configuration of triangles. Whenever we've got these parallel lines, these 2 triangles must be equiangular, because obviously these 2 angles are the same, vertically opposite angles. These 2 angles here must be the same, alternate angles with the parallel lines, and then without even bothering the other one, if 2 are the same, all 3 are the same, but those are also the same because you've got alternate angles again. Equiangular triangles, so they must be similar to each other in that one's a multiple of the other. This side was of length 6, being half the length. This is of length 12, which means the linear scale factor is 2. This triangle has its lines twice the size of the lines in that triangle. But it's areas you're talking about, which means that this triangle, if the scale factor is, taking it this way around, 2 to 1 for the lines, the area scale factor must be the square of them, must be 4 to 1. That's got 4 times area of this one, because an area is a product of 2 perpendicular dimensions. It's easy to show it just by doing this. If I take this triangle, which is half the linear size, and pop it here, then you can see straight away I've got 1, 2, 3, 4 of them there. The big triangle C is 4 times triangle A. So that would make my 4th equation I can now use. C is equal to 4A. So the simplest way would be pick any equation with a C in it and replace it by 4A. So I'll take these. Equation 1, which has got an A and a B. Equation here, call that 2, which has got a B and a C, and I'll call that my 3rd equation. Then if I do this, if I substitute that, if I put 3 in 2, that'll produce b plus 4a equals 108. Put on this next one, number 1, b plus a equals 72, and subtracting them would then give me, if I do a subtraction, would give me 3a equals 36, which means a equals 12. And then straight away, using 3, I've got c equals to 4 times 12, which equals 48. And from this one here, if a is 12, straight away from number 1, I've got b plus a is 72. So if a is 12, that means that b is equal to 60. Then lastly, from whichever one you want here, because I only need the 4 equations, so whichever one you care to use, that would be either one of them could be your fourth linearly independent equation. Maybe just picking this one here out as a candidate for number 4. I've got from number 4, a plus d is 36. So 12 plus d is 36. So d is going to be 24. So there's the answers.